Okay, let's unpack this. For the last couple of years, the world has been, well, completely hooked by the skyrocketing benchmark scores of these large language
Oh,
models.
absolutely. You see the headlines everywhere, right?
Yeah.
GPT-4 aces the BART exam, Llama 3.1 hits some new high on MLU. They're solving these incredibly complex math problems.
And if you're like most people, you look at those scores, the MMLU, Big Bench, all those static tests, and the logical conclusion seems to be, well, the higher the score, the more useful the AI is going to be for me.
That's the assumption, but it's a deeply flawed one. This reliance on isolated performance is fundamentally misleading when we talk about real-world use, where there's always a human in the loop.
It feels like the only metric we've been given, though.
I know, but the core issue, and this research really highlights it, is that those benchmarks only test the model working alone. They're solving problems from these perfect, non-interactive prompts.
Which I'm guessing creates a really bad case of benchmark optimization. You get a model that's amazing at passing a test, but maybe not so great at being a partner.
Exactly. And this narrow focus leads to three big, widely recognized problems. First, the models are just less effective on messy, real-world tasks that need some back and forth.
Okay.
Second, and this is maybe more troubling for collaboration, they show really limited collaborative skills. They often fall into what researchers call sycophantic behavior.
So they just agree with you to seem helpful, even if you're steering them completely wrong.
Precisely. They become agreeable parrots instead of, critical thinkers. They're just trained to predict the next helpful word.
Which often means just confirming what I already think.
Right. And the third issue is the most critical, I think. Optimizing for these isolated scores pushes developers towards imitating what humans can do, rather than figuring out how to complement them.
And that shift from imitation to complementarity, that feels like where the real value is. And that brings us right to the source material for this deep dive.
It does. We're looking at research that really moves past this single score idea. It introduces a principal framework to actually analyze the human-AI interaction itself.
Using what they call a novel Bayesian item response theory model.
Right, or IRT model. Its whole job is to rigorously quantify something they call synergy.
Which is what exactly?
It's the measurable, quantifiable uplift in your performance when you're actively working with an LLM.
So we're changing the measuring stick from how smart is the AI on its own to how much smarter does the AI make the team.
That is the mission statement of this whole approach.
And our mission for you, the listener, is to understand why working with AI is a completely different skill from working alone. We're going to pinpoint this specific human skill that determines your success in this new world. And spoiler, it has nothing to do with raw intelligence. It's something much more social.
Okay, so let's get into the experimental setup. They created this really fascinating sandbox to test these ideas.
Yeah, they took the classic MMLU benchmark and adapted it into something new called ChatBench. It had just under 400 questions from really diverse fields, mathematics, physics, even moral reasoning.
And they ran 667 human participants through this test in 3 different ways, which is so crucial for the math later. You had people working alone, you had the AIs working alone, and then the most important group,
Right.
the human-AI pairs, interacting through a chat to solve the problem.
And they used 2 very different models. You had GPT-4o, the current heavyweight champ.
The state-of-the-art.
And on the other side, Llama 3.18b, a model that is orders of magnitude smaller and, by all the standard tests, much, much weaker.
And people were randomly assigned to work with one or the other. This comparison is just essential because it lets us test that central question. Does a model's raw power translate directly into being a better partner?
And to figure that out, you need the horsepower of this IRT model. So let's take a second to really unpack what that is. Why is it so powerful here?
Okay, so think about a standardized test. Your final score is a mix of your own ability and how hard the questions were. Right? IRT is a statistical framework that lets you rigorously pull those two things apart. It knows that if a really smart person gets an easy question right, that doesn't tell you much. But if a lower ability person gets a really hard question right, that tells you a lot.
So it's a more nuanced way of measuring than just counting right and wrong answers.
Exactly. And the real novelty here is that they add a third factor to the mix. The model can separate and quantify 3 different things: the difficulty of the task, the individual human solo ability, which they call theta, and then this new thing, collaborative ability, or kappa, which only shows up when the human and AI work together.
That is brilliant because it means when you measure that boost, you know you're measuring the actual effect of the interaction, not just, an easy question or user who is already a genius.
It's a much cleaner signal.
Yeah.
Now, let's look at the raw data, just the basic results. Humans working alone, they averaged about 55.5% accuracy.
Okay, so a little better than a coin flip.
Pretty much. The standalone AIs, though, showed that big gap we expected. GPT-4o hit a really strong 71%, but the smaller Llama model, only 39%.
Wow, so Llama was failing more than 6 out of 10 questions on its own.
It was, but this next part is where it gets really interesting and genuinely counterintuitive.
This is where the synergy idea lights up.
It really is.
Yeah.
When humans were paired with an AI, performance jumped across the board. And crucially, even that Llama 3.18b model, the one that failed most of the time alone, it helped humans perform significantly better than they did on their own.
Get out.
And what's more, if you look at the two AIs when they had a human partner, that massive 32-point performance gap between them, it shrank dramatically.
Okay, so you have a model llama that by every conventional measure is weak, yet it was a surprisingly effective partner. Why? How does a model that's wrong 60% of the time still boost human performance so much?
Well, it's likely providing a kind of complementary cognitive function. It might not spit out the right final answer, but maybe it provides a useful first step. Or it generates a few hypotheses the human hadn't considered.
Or it just surfaces a piece of information that the person forgot.
Right. The human doesn't need the AI to be perfect. They just need it to nudge them out of their own cognitive rut.
And this framework actually lets you put a number on that nudge.
It does. Using the full IRT model, they quantified that average synergy. Llama 3.18b boosted human performance by 23 percentage points on average.
Wow.
And GPT-4o, being the stronger model, still had an edge. It boosted performance by 29 percentage points. So it confirms GPT-4o is a better collaborator. But the main takeaway is that both models created huge, meaningful synergy. And this quantitative difference leads us to what I think is the most important conceptual breakthrough in this paper.
Which is?
The finding that individual problem-solving ability, that theta, and the ability to work with an AI, kappa, are, well, they are not the same skill. They're statistically distinct.
So you're saying that being a brilliant solo problem solver doesn't automatically make you a good AI collaborator?
That's exactly what the data suggests. They ran a very rigorous model comparison, and the model that estimates these two abilities separately, theta for solo and kappa for collaborative, it just fit the data so much better than a simpler single ability model.
So this confirms it. Effective collaboration with an LLM is a totally distinct skill.
It's a latent skill, yeah, like
Yeah.
learning a new instrument or maybe mastering a complex sport. It's not just using a simple tool.
I think I see the connection now. If I'm a brilliant programmer, my solo ability, my theta, is super high, but if I don't know how to prompt the LLM or I refuse to engage with its suggestions, my kappa could be really low.
That is a perfect analogy.
It's like a great writer who just can't co-write a script because they won't listen to their partner's ideas.
It holds up perfectly because an LLM isn't a calculator or a notebook. Those tools are predictable. An LLM has this semi-autonomous agency. It generates novel ideas. Its output can be unpredictable. You need a mental model of what it knows and its limitations and how to structure the conversation. That is a completely different cognitive exercise from just solving the problem yourself.
Okay, so let's dig into the dynamics of this boost then. Who benefits the most from this cognitive amplifier, as you called it?
They looked at this from two angles: the difficulty of the task and the user's own ability. For task difficulty, the results were really clear. The highest AI boost, the biggest jump in performance, happened on the most difficult tasks.
So it's not just helping you with grunt work, it's filling in the high-stakes gaps where your own reasoning hits a wall. Like an expert consultant you call in only when the problem gets genuinely tough.
Precisely. Now, for user ability, this work is a little more subtle. When you look at absolute performance, just the final score, the highest ability users consistently got the highest scores, even when they were working with the AI.
But wait, if the smartest people still score the highest overall, doesn't that just mean that raw solo ability is still what matters most? How much of an equalizer can this really be?
That's a critical question. And it confirms something they call strong skill complementarity. Smart people are still the top performers.
Yeah.
But the story changes when you measure the relative boost.
The percentage point gain they got over their own solo performance.
Exactly. That tells you how much the AI actually improved them. And that relative boost was highest for the lower ability users.
Ah, okay.
So this suggests a really important equalizing effect. AI collaboration isn't a magic bullet that completely closes the gap between highest and lowest performers, but it provides the largest relative gain to those who needed that cognitive boost the most. It helps level the playing field.
Which brings us to what I think is the most fascinating part of this whole thing, because it identifies the actual human skill that unlocks this collaborative ability, this kappa, and the answer is theory of mind.
Theory of mind, or TOM. It's a cornerstone of how we think socially. It's your capacity to represent and reason about the mental states of other people, their beliefs, their goals, their intentions, what they know and don't know.
Historically, it's what lets us work together in teams.
It's the glue. It allows us to coordinate and fix errors.
So if I understand what you believe, I can better predict how you'll act. But
Yeah.
how does that apply to a machine that doesn't actually have a mind?
The human has to sort of project a belief system onto the machine. You have to build a simulated mental model of what the LLM can and can't do. And the study found a dramatic effect here.
Okay.
Theory of mind does not significantly predict a user's solo problem-solving ability, their SATA.
That makes sense. Your ability to think about other minds doesn't really help you solve a physics problem by yourself.
Theory of mind is a significant, strong, positive predictor of a user's collaborative ability with the AI, their kappa. People who are better at inferring and adapting to another's perspective achieve way better results when working with the LLM.
That is wild. We spend our entire lives training for IQ and domain knowledge, but the thing that unlocks the most value from our AI partners is this soft, social, perspective-taking skill.
It's the cognitive interface.
Mm-hmm.
High-time users are just better at anticipating the LLM's weaknesses, correcting its tendency to just agree with them, and guiding its focus.
So is this theory of mine like a fixed personality trait, or is it something people were doing dynamically, moment to moment in the conversation?
That is exactly where the researchers went next. They treated Tom not just as a stable trait, but as a mechanism that you express through your behavior.
How did they measure that?
They used a really cool technique. They used another LLM, which they call the language model, as a research assistant, or LMRA, to basically score the user prompts for Tom signatures.
So an AI assessing a human's theory of mind, how does that work?
It analyzes the linguistic cues in the prompts. Did the user acknowledge the AI's last response? Did they notice a knowledge gap? Did they ask for clarification because of a previous error? And crucially, did they set expectations for the AI's perspective?
Can you give me an example? A high Tom prompt versus a low Tom one?
Sure. A low Tom prompt would just be, what is the answer to this physics problem?
Okay, very direct.
Right. A high Tom prompt might say something like, I'm solving this for a high school competition. I already know thermodynamics, but I keep getting stuck on the final calculation. Can you generate 3 different ways to do the calculation and highlight where I might be going wrong?
That level of context tells the AI exactly what model of the user's mind it should be working with.
Precisely. And they found that trait-level Tom, the user's stable measured characteristic, was strongly related to getting higher quality AI responses. It is that essential interface, and it's independent of the user's raw intelligence.
And you said that even the fluctuations mattered.
They absolutely did. They found that even moment-to-moment fluctuations in perspective-taking, question-by-question variations in how well you express your needs, also had a significant impact on the quality of the AI's response in that specific moment.
So what does this all mean for how we should design AIs? The fact that Tom varies dynamically, it must mean LLMs shouldn't just have a static user profile for you.
This is the practical takeaway for developers, I think. It means prompt histories shouldn't just be a log of questions. They should be seen as signal-rich, dynamic behaviors. If a user gives a high Tom prompt with clear context, the AI should recognize that social state and adapt its behavior instantly to maximize the synergy right then and there.
Maybe by giving a more nuanced response instead of a single definitive answer.
Exactly.
So this research really does fundamentally change how we should be measuring success with generative AI. We can move past that single static score and use this Bayesian IRT framework to actually quantify human-AI synergy.
And we can successfully separate out that solo ability, theta, from the completely distinct collaborative skill, kappa.
And we've identified the key human ingredient that drives that synergy, theory of mind. It's the cognitive mechanism that turns the AI from just a powerful, erratic tool into a genuine high-performance partner.
The implications for LLM design and training are massive. It suggests developers should shift their focus.
Hmm.
Stop just optimizing for general helpfulness or imitating human test takers.
And instead,
Instead, build LLMs that are explicitly sensitive to these social and cognitive cues that humans use, like belief tracking, perspective taking, and figuring out what a user actually needs in that moment.
it's telling designers to focus on the quality of the conversation, not just the final answer. The system's performance is an emergent property of that whole interaction.
Which means the model has to become a much, much better listener.
So, since we know that this dynamic, moment-to-moment perspective taking influences success, here's a final provocative thought for you to mull over. Future AI partners might need to be designed not just to track your prompt history, but to actively recognize and adapt to your shifts in social cognitive state. Imagine if, when you show a high moment of theory of mind, that variation actually triggers or suppresses time-relevant circuits inside the LLM itself. It could create this instantaneous, feedback-driven cycle of collective intelligence that's constantly trying to find your cognitive peak.